In example 1-3, we are looking at a differential manometer. This differential manometer measures the difference in pressure. Now, what is the difference in pressure we are talking about? As the fluid flows from left to right, there is a pressure difference which generates this flow. And we are interested in the pressure difference between the points 1 and 2. So what we do is, we are not really interested in what the pressure at point 1 is and what the pressure at point 2 is, but the difference. So we use A and B, which are at the same level in the same fluid, oil, and we will examine the pressure difference between A and B, which will be essentially the pressure difference between 1 and 2. So if you look at the question, it says that oil is the fluid. We have here the density of oil, 900 kilograms per cubic meter. We also have the measuring fluid, which is mercury, 13,600 kilograms per cubic meter. So let's phrase the hydrostatic equation. Basically, what we are saying is the pressure at A plus rho G, the height, where the rho is oil. That's the left-hand equation. The pressure at A plus rho G, height, the hydrostatic pressure, at this point is equal to the pressure B plus rho G, height. But this is the height of mercury. So if you notice on either side of the equation, on the right you have mercury, on the left you have oil. What we now do is we will evaluate this, simplify, and as you can see in the next line, we have grouped the pressure difference between A and B is the difference in the density between mercury and oil times G times 0.25. So the pressure difference PA minus PB, which is essentially the same as the pressure difference 1 to 2, can be easily evaluated as given by this final line where the figures represent the density differences times G times the difference in height in the manometric fluid. Now, with a bit of careful calculation, we will then be able to evaluate the pressure difference, 31.15 kilonewton per meter squared, or 0.31 bar. Now, we have to be very careful. Let's go back to our equation and the diagram, and you notice that we have to be very careful that we are using the pressure A as a proxy for 1 and the pressure B as the proxy for 2, because between 1 and A rather, and between 2 and B we have the same fluid, and the hydrostatic pressure between the 2 points are the same. So think carefully about solving this. The trick is we need to know where to draw the hydrostatic line to start our pressure measurements. This ends the solution.